Okay, video lesson on the decimal counting system. The Egyptians, just by way of contrast, the Egyptians used hieroglyphs, and this picture here, the lotus flower, represented 1,000, so 1,000, 2,000, 3,000. Then we've got coils of rope, the heel bone, and the strokes. So those represent thousands, hundreds, tens, and ones. So with their counting system, the position of the pictures didn't matter. So that number there, you can understand it even though the number was broken up and the pictures lying in different positions. With our counting system, however, the position of the numerals, the digits, is important. That number there, broken up number, is it 384? Is it 483? You can't tell, because in our system, counting system, the exact position of the digit is vital. So we have ones, then tens, then hundreds, then thousands, then tens, thousands, 100,000s, and millions. And one way to imagine any number in our counting system, the Arabic counting system, is to imagine as if it were drawn with a grid superimposed on it. So here are the different columns which are not normally written in for us. So here we've got some numbers with the numbers lined up with this imaginary grid to help us be really clear about what the value of each digit is. So the first number here is 1,234.567. So the 5 is in the tenths position, that's in the hundredths position, and that's in the thousandth position. So it's tens, tenths, hundreds, hundredths, thousands, thousandths. This number here is 5,000. This number here is 5,000ths. So there's a bit of sort of symmetry going on here. So tens and tenths, hundreds and hundredths, thousands and thousandths. And they kind of, the ones position or the units position is the kind of central column, and then the other ones are kind of symmetrical around it, either side of it. This number here is 1,200,000. Wait, speak it. 1,234,567.89, 8 tenths and 9 hundredths. Right. Now, one problem that people often get stuck with is comparing and maybe adding or subtracting decimal numbers. If you've got decimal numbers where the number of decimal places appears to be different, the recommendation to kind of make them look alike so that you have no problem comparing them is to insert the extra zeros so they all have the same number of positions or figures after the decimal point. And if you do this, then it's then very easy to see that that's the smallest of the three numbers, then this one, and then this one, and then this one. So it's a bit like as if that was 9, that is 60, that is 67, and that's 600. That's not quite a correct way. It's not the correct way of saying it, but it might help you to follow what's going on here. So if you want to compare the size of decimals, or to add them, or to subtract them, a strong recommendation is to make them all look alike by adding zeros, so that they all have the same feel or look to them. And that will do for now.